Today we're going to talk about welding electrodes. First thing we need to talk about is the classification of each rod. So on each welding rod there's going to be a number on there. We're going to talk about what that number means. But first of all, we need to talk about where that number comes from. For example, we have here on the screen an E7018. Okay, that's a type of electrode for SMAW or stick welding. Okay, so the AWS, here's another acronym in welding. The AWS stands for American Welding Society. The American Welding Society has a classification system for welding electrodes, so you know when you pick up a rod you can read those numbers on there and you know what it means. Okay, so each rod's going to have one on there. So let's go through and show you what each number means on the welding electrodes. First of all, this E, this stands for electrode. This tells you that it's meant for welding, arc welding. If you pick up a rod and it doesn't have an E on there, you definitely want to double check before welding with it. It could be a brazing rod, it could be something else not meant for welding. Okay, so first E means electrode. Okay, the next 2 to 3 numbers, in this case 2 numbers, the 70 is the tensile strength. Okay. And that's measured in kpsi, or thousands of pounds per square inch. So a 70 would mean the tensile strength of this filler rod, this welding electrode, is 70,000 psi, which is just crazy to think about, the amount of strength that this weld bead's going to have. If you think 70,000 pounds, if you think about like a full-size pickup truck, my truck I have, I believe weighs about, give or take, about 7,000 pounds, maybe a little bit less. So if you think about that, that is 10 trucks piled on top of each other. That's how strong the tensile strength on that weld's going to be. Incredible. Okay, so the first 2 to 3 numbers. Sometimes there'll be a third number in there, like a 110, and then the last 2, that would be 110,000. Okay, this one here, this is a 7018. Okay, the next number, this one right here, this tells us the positions that we can weld with this rod. Okay, so we're going to have a 1, a 2, or a 4. A 1 means all positions. 2 is flat and horizontal. Fillet welds. And we'll talk about why in just a minute. And a 4 would be flat, horizontal, vertical down, and overhead. Okay, and then the last number is going to tell us the type of flux or coating on the rod. And the polarity or the current that we can use. And we'll get into current later in the next section. Okay, positions. So this particular rod is an all-position rod. 7018 is a really common rod in construction, and that's probably one of the main reasons is, well, first of all, it's a low hydrogen rod, so it's for structural stuff, so you don't get hydrogen cracking. But on top of that, you can weld in all positions. It's kind of a good all-around rod. Okay, so let's look at another rod. To erase this here. 7018s you're going to use a lot in our welding shop. You're going to practice with those quite a bit. Let's do an E7024. Okay, so E is for electrode. 70 is 70,000 again. 2 is a flat and horizontal fillet. Okay, we'll talk about why in just a sec. And then 4 is just telling us the type of coating it is. And there's quite a few numbers in this last category here. I don't have them all written down. Lots of times there'll be a chart that shows you all the different rods and what they're used for and what they're good for and what they're not good for and the coatings and all of that. But we just, for right now, all we care about is what each number or set of numbers means when you look at the classification on a stick electrode. Okay, so 2. This rod here, 7024, is considered a high deposition rod. Okay, so let's talk about that first. Let's define that deposition rate. Turn on my pen here. That's a term you're going to need to know. So let's define that real quick. It's the rate at which metal can be deposited by a given electrode and that's usually measured in pounds, so lbs per hour. So a rod will have a rating of, I'm just pulling this off the top of my head, maybe a 7018 you can weld, if you continuously weld, you can weld 100 pounds per hour. And a 7024, let's say you can do 175 pounds per hour. So the 7024 would be a higher deposition rate. Okay, so what that means is when we strike an arc on a 7024, it's going to lay down a lot of metal fast. Okay, so knowing that, we need to watch what positions we're welding in it with it. If we tried to weld an overhead position, meaning you're welding over your head, and that electrode's putting out a bunch of molten metal so fast that it can't solidify before it starts to drip, you're going to have molten metal dripping on your floor, on your head. So it restricts, a high deposition rod is restricted with what positions it can weld. So flat, you're using gravity to hold it in, or a horizontal fillet. So if I'm looking at the side here, and we need to weld across a plate, we can do that. Overhead, you're trying to weld something and you're standing here, that metal is going to be dripping down on you. and sagging and not making a good connection, a good weld. Okay. So deposition rate, know what it means. Will definitely be on the quiz. Okay, so let's do another one here, another rod that we're probably going to be using in the shop a little later in the year. It's a E6013. Okay, E is for electrode. 60,000 pounds. 1 means all positions. And 3 is the flux. What's in the flux? Sometimes they put powdered iron in it or whatever. There's a bunch of different types of fluxes. And what current we can weld on. Whether that's AC or DC. You'd have to look at the chart on that one. Okay, sizes of rods. So the diameter of the rod. So typically we'll be using 70/18s in the shop. Usually I order 1/8 inch, but we could get 3/32 or 5/32. There's all sorts of different sizes. It depends on what you're welding. Okay, if we're welding thin metal, say we're welding some metal that is, 1/8 inch. We want to do a corner joint here. Well, if our weld is between 1/8 and 1/4 of an inch, an 1/8 inch rod is going to be fine. Okay, it's going to put down enough metal. We can probably do this in one pass. But if we're welding a 1/2 inch piece of metal and we want to put in a 5/8 or a 3/4 inch weld, an 1/8 inch is probably only going to be right there. You might need to do 5 or 6 passes to get that fillet size. So that might be a situation where you go with a larger diameter rod, put down more metal to make your fillets bigger each pass. Something you need to keep in mind though, for those of you that have welders at home, before you go buying bigger rods, like a 3/8 rod, you need to make sure that your welder can actually run those rods. And what I mean by that, and we'll get into it a little bit later with the electricity, you got to have enough amperage to melt the welding rod, the welding electrode. So just a rule of thumb, if you take your rod size, so that's 1 inch, or 1/8, excuse me, and you convert that fraction into a decimal, so you'd be 1 divided by 8, it writes that very well. You go to your calculator, 1 divided by 8 equals 0.125. Okay, that right there, if you take that number, that's a ballpark good starting point for amperage to run that rod. Now, with 125 amps for an 1/8 inch 70/18 might be a little bit on the high side, but like I said, it's just a ballpark. It kind of gives you an idea of how many amps you're going to need to run for that rod. So if you got a welding machine at home and it's a 200 amp machine, well, if you go and buy 1/4 inch rods, right there is 250 amps that you're going to need to run that rod. You're probably not going to be able to run 1/4 inch rods with a 200 amp machine. You're going to need a bigger machine. 3/8 is 375, 375 amps. That's a big industrial machine. Okay, so something to keep in mind with diameter of rod. 1/8 inch is pretty standard for most applications. When you get into the heavier rods, like I said, you need more industrial rated machines. So, on the quiz and on the state test at the end of the year, there'll be questions on there that say, it'll give you a rod number, whatever it might be. And it'll have you break it down just like we did. What does the E mean? What does the 70 mean? What does the 1 mean? What does the 8 mean? And you need to be able to pick those out. Okay? So that pretty much covers the very basics of welding electrodes. We didn't go into polarity or current, whether it's AC or DC, or DCEP or DCEN. We'll cover all of that in the next section for electricity. Okay.